Hey, hello once again, fellow flight simmers and cockpit builders. Welcome back to another one of my Back to Basic videos. Today we're going to be talking about potentiometers or analog inputs. Actually, this is one of the only videos I think that of certain type of components that I had not recorded before. So this is not actually going to be an updated one, but it's going to be the first one of this for this particular component type. So potentiometers are analog devices. So kind of like the opposite of switches or push button switches or encoders, which are digital, which is either they're on or they're off. Potentiometers have a range of motion. So they can be on a little bit, they can be on halfway, or they can be on all the way. So it's a variable signal. They're they're called variable resistors. That's what they are. So let's take a look at this picture here, and we can see that there are a lot of different types of potentiometers. So the normal ones that I've only used is pretty much the rotary pot and then the slide potentiometer or the linear potentiometer. But you can see that we have dual gang, which means they have two sets of connections. We have a single turn pot, which I'm not really sure what the difference is between that and a rotary pot. Concentric pots are like the dual rotary encoders that we talked about, but these have two potentiometers embedded, one within the other. Multi-turn pot, I actually have one of those that I'm going to show you here in a little bit, but I really haven't found what to use it for. I've never seen servo pots. Trimmer pots are probably used like for instruments, musical instruments. Then there's also digital pots, preset pots, and of course, like I said, right now, linear and slide potentiometers, which I am going to be demonstrating today. So let's look over here on my little work table here, and you can see that, like always, I have a wide assortment of different potentiometers here. And as everything else, you can get these in all kinds of different sizes and colors and materials and everything. So, these right here are about the normal standard size. And this one right here is a much smaller one of the same type. I kind of like this one because it won't take up a lot of room in your wiring panels or whatever. And then you got, this is a 10 turn potentiometer, but basically it has a much finer range of motion or detection of the signal because it takes a lot of turns to go from the zero all the way to its maximum range. So those are kind of cool when you need a lot of granular sensitivity, I guess you can say. And then these right here, they're smaller. I think I took these out of a joystick if I remember correctly, but I'm not exactly sure. And these right here are the smallest ones that I've gotten a hold of. I pretty much just use them for testing purposes. I think when I did the LCD, how to use LCD panels video, I used that one to adjust the contrast or the brightness of the backlight. And then here are the linear or slide potentiometers. So this one right here is a pretty basic one. It has only 3 terminals. So one would be for power, the 5 volts, one would be for ground, and then one would be the output, which is going to have the variable voltage coming out of it. But this one right here, this one is a little bit more complicated. So this one here, for example, one of these and one of these will be the positive and the ground for one of them, and then this will be the output. And then the second set down here would be the positive and the ground for the second half of it, and this would be the output. So basically this is like having two potentiometers built into one, but of course they're both going to be moving with the same values as you slide it up and down. All right, so now we're going to go over to their website here, SimVimX.com, which I always recommend you guys come and read. And we're going to go over to the hardware section, and we're going to go to analog input. So as you can see, just in the little picture here, analog inputs can be used for a lot of things in our simulator. So obviously we can use it for pitch, we can use it for roll, for the for the yoke, we can use it for yaw, for the rudder, we can use it for the brakes, the parking brakes, we can use it for the throttle, the mixture, the prop control, the cowl flap, speed brakes or spoilers, and for the nose wheel tiller on airliners. We can also use it for brightness controls for the lighting. We can use it for the volume of the radios. And in helicopters, you can use it for the collective, the rotor brake, and we can also use it for the trim, for the elevator trim, the roll trim, or the rudder trim. But I don't recommend it. I've seen some kind of jumpiness to it, so I'm not going to get into it here. but I don't recommend using them for the trim. Okay, so now we're going to basically look at the basic wiring here first in their pictures and diagrams here, and then we're going to have to actually look at it on my table. But as you can see, they only have 3 pins, so it's pretty quite simple. One of the pins is going to go to ground, one of them is going to go to 5 volts, and the other one is going to be the output pin that's going to go to the pin on the Arduino, A0 through A15, or to a analog input multiplexer if you decide to use one of those. And looking at this picture here, you can see that he has 2 examples. Actually, he has 3, but we're not going to talk about the photoresistive right now. So here's a rotary potentiometer. So as you can see, one of the terminals goes to ground, one of them goes to the 5 volts, and one of them goes to the pin on the Arduino. Same thing for the linear one, like the one I showed you right now. One of the pins is going to go to 5 volts, which should be a separate power supply, not coming from the Arduino. Another one's going to go to ground, and then the other pin, the output pin, is going to go to the pin on the Arduino. Now keep this in mind right here, because there is a capacitor that they recommend that you put so that it can smooth out the ripple of the sensor. So we're going to be talking about that a little bit more in a little bit. Okay, they recommend that you use any potentiometer between 3 and 10 kilo ohms. They say you can pretty much use any potentiometer, but when you get into the very high values, like if you have a 50K or a 100K, it could be more susceptible to electrical noise from the power lines. So they recommend 3 to 10 kilo ohms only, and they say that 5K is generally fine. So if you want to stay right in the middle range of that recommended range, then 5K would be right about the recommended one. Okay, now we're going to go over to more wiring diagrams here real quick. It feels kind of like I'm just reading this to you, but I'm hoping that whatever other context I talk about, will help it a little bit easier to understand. So as everything else that we've talked about in the past, we can use, of course, a 5-volt power supply, which is going to be a separate power supply, not coming from the Arduino, is going to be all together going to one of the pins of each of the pots, right, of the potentiometers. And then he recommends that if you're going to have a bunch of potentiometers in the same area, then you just ground that between the 5-volt rail and ground, which is a common ground, throughout your system. So instead of using one capacitor on each potentiometer, you can just basically use a capacitor on the 5-volt line to the ground, and then that'll pretty much cover it for all of them. And then of course all the grounds are going to be linked together, and they're going to go to the common ground, but each individual output pin from each potentiometer is going to go to the individual pins. And as I've mentioned before, I think I've mentioned this in a lot of my other videos, you can use all the analog pins A0 through A15. You can use them for regular switches, but push button switches, toggle switches, encoders, or whatever. So right here, he just kind of demonstrate that he used A14 right here to connect a multiplexer, an input multiplexer with some push button switches on it. So just keep that in mind. And you can also use, like I mentioned before, one of these A0 through A15 pins, you can connect one analog input multiplexer. All right, real quick here, back to my table here. I just want to go over a few things. Most potentiometers that I've noticed, they have a range of about 270 to 330 degrees of motion. So when you go to, one extreme, that's going to be the beginning of it right there. And then you turn it. This one seems to be about 330 degrees. And this one, of course, is not going to be like that because it takes 10 turns to go through its full range. But this one right here, you can see right there that the little wedge is over here right now. And then when I turn it all the way, the little wedge is over here on this side. So that's about 330 degrees also. But I have one over here, which I'm actually going to be using in my example. And these right here, this is another thing I wanted to talk about. Some of these potentiometers actually have a switch also embedded into them. But it's not a push button switch like the rotary encoders. This is actually a clickable on and off switch. So you go way to the end of its range, and that'll be the button. So if you can imagine, like for example, turning on an instrument, a radio, and then you turn it on, and then you go through its full range of volume. So that's what these two connections over here at the end are for. And these right here are for the potentiometer. And this one right here, So if we go to the beginning of its motion there, this is where the button would be. So you turn on the button and you can see that it's kind of pointing that way. And then when we go through its full range of motion, it's about right there. So it's about 270 degrees or so. There is a thing here on the website where it talks about calibration and also the range of motion. So if you, for example, were using a potentiometer for something that you didn't want it to do the whole 330 degrees of motion, you can actually calibrate it so that it only uses a partial of its full range of motion to make the simulator do the whole range of motion that it's supposed to do. So you could actually do this with gears if you're that handy, where you could actually just move the handle or the knob a little bit, but it'll actually make the potentiometer move through its full range of motion. And then of course you have the full range of motion. Just for example, with a linear potentiometer, you can have it just go all the way from one end to the other to complete that motion. All right, and then way at the bottom here, I'm going to just mention it very rapidly because it is also part of the analog inputs. So he talks about that you can also use photoresistive sensors and magnetoresistive sensors, which are like Hall effect sensors, which react to a magnetic field. And these pretty much behave the same way as a potentiometer. They basically just detect varying amounts either of light or of a magnetic field, and that's what's going to tell the sensor to output a certain voltage so that the simulator can translate it into that range. But I'm not going to be going over those in this video, just potentiometers. Okay, now we're going to talk about the wiring part of this, of potentiometers. So as you can see, I have here a little power rail that I have already connected ahead of time. So basically these wires are coming from a 5-volt power supply that I connected for the purposes of connecting the potentiometers. And I have the ground, if you can see there here, this little white wire is going to the common ground. So anytime you use a separate power supply for powering LCD displays or LEDs or even these potentiometers, you need to connect the two grounds of the separate power supply and of the Arduino together. So that's what I'm doing here with this wire here. And remember, we need to have a capacitor between the ground and the 5-volt rail. So this right here is a 1000 microfarad capacitor, just like they recommend. And this is a 10-volt one. So we're only working with 5 volts. So, if you have twice or 3 times the voltage requirement, then that'll be fine. So these actually do have a negative and a positive. So you need to make sure that you connect it the right way. So in this case, this is a negative. So I'm going to just go ahead and put that on this side. And it's going to be just connected right there between the 5 volts and the ground rail. All right, I'm going to start off with this sliding potentiometer here. And we're going to actually use this one for the roll axis of the airplane. So my ground, you can connect, since both of the grounds are now linked together, you can actually connect the ground to the main common ground over here, or I can just connect it to here because they are going to be connected anyways. And then the positive right here is going to be connected right there. And then this one right here, I'm going to connect it on pin A8 of my Arduino. So that's going to be the roll axis. All right, now I'm going to get this rotary, and we're going to use this one on A12, and we're going to use this one for the throttle. So once again, we can put the 5 volts is going to be connected to the 5-volt rail coming from that other power supply. And then I got the ground here, and I'm just going to go ahead and connect that one over there. And then the pin, this one is going to go to pin A12. So that'll be it right there. This wire over here, this one also has a switch. So that's going to be the wire for the switch, but I'm not using that right now. So I'll leave that alone. Okay, the next two potentiometers we're going to be connecting to an analog input multiplexer. So if you notice, I took the signal pin here that comes out and I put it on pin number A15 over here. So we're going to make that into an analog input multiplexer. And the first one we're going to connect to that one is this rotary potentiometer that I showed you guys a little while ago. So as always, I'm going to connect the ground over here to the common ground. I'm going to take the positive over to the power rail over here from the separate power supply. And the middle one here is the output, so I'm going to go ahead and put that on pin number 10 of the analog input multiplexer. And finally, I have another slide potentiometer here that I have already pre-soldered and connected everything to. So we're going to go ahead and connect this one to the pin number 15 and the analog input multiplexer. So I'm going to take this one here, come around the bottom, connect it there. This is going to be my positive here, so that's going to go to the 5 volts. And then this is our ground, so we're going to connect that one. Actually, I'll just connect it here. Okay, now that we got all that connected, let's go back over to the website here, and we're going to go over to the configuration tool and start assigning functions to our potentiometers. So remember, the first thing that whenever you're going to assign anything, you need to first open up the pins of whatever type of devices you are planning to connect. So basically we have to go to the analog input for this one, and it's going to have, it's going to give you the 15 analog pins that are available to connect. And remember, I told you we're going to be using that multiplexer as an analog input multiplexer. So that's going to be the first thing we're going to do. So I connected it on pin number 18. So basically, if I click on any open pin, it's going to ask me if I want to add an analog multiplexer, and I put OK. And remember, you can only connect one. So if I try to do that again, it won't do anything anymore, as you can see. Alright, so there's the analog multiplexer on pin number 15. So now if we go back to our bench here, remember this sliding potentiometer we're going to use for the roll axis of the yoke. So we're going to go ahead and do that. So we got to go to cockpit main controls, and then we're going to basically go to the roll, and we're going to put that on pin number A8, which is where I connected it. Okay, the next one we're going to connect is this rotary potentiometer, which I have connected on pin A12, and that one we're going to use for the throttle. So if we go back over to the website, so for that one we have to go over to the cockpit main engine control, and we're going to go to throttle. So we're going to do this one here. It's going to be single, and that one is going to be on A12, which is right there. So that's all we're going to do for the direct connecting pins. Now we got to go to connect for the input multiplexer. So for that, we need to click here on MUX so that it can open up the window for the 16 pins that are available on the analog input multiplexer. And I believe we had said that on pin number 10, we're going to do the pitch axis for that. So we go back to our main controls here. We go to pitch, and then we're going to put that on pin number 10. And then for pin number 15, we're going to do the flaps. So I think we got to go to a little bit here on the bottom, and we can do this. Select that, and that's going to be on pin number 15. And just remember that, like right now I have the analog inputs open. So anything that I hover over that's an analog device will turn yellow. Everything that I cannot assign will be red. So you can see that most of these are red, but when we go over to this, you can see there's a lot of yellow items here. And so that's how you can figure out what you can assign to this type of inputs. So that's pretty much it. We already assigned all 4 of them, so we're going to go ahead and save our configuration file, and we're going to go, it's going to be once again in our X-Plane 11 resources plugins SimVimX folder, or X-Plane 12 if that's what you're using. So we're going to call it data like always, and we're just going to go ahead and save it. Okay, now we can go over to our simulator here, and first thing we need to do is, well, right now it says that the board is not connected for some reason, so I guess we can just go ahead and put reset plugin. There, now it's connected, and just to be on the safe side, I'm going to go ahead and do the reload configuration here. Okay, so remember, another thing that is very important with analog inputs is that we need to calibrate them so that the plugin knows what its full range of motion is, or detection of the input voltage or the output voltage in this case. So we are going to, let me get myself out of the picture here, and we are going to bring up the SimVimX analog calibration menu here, and I'll just put it right here. So right now we're going to do the flight control of the roll, so that's going to be this one right here. So if we click on calibrate there, you see that it tells you freely move the analog axis A8 between minimum and maximum position, then leave it in the central position before finishing the calibration. Press finish to save the calibration data and the connection will be reset. So what we need to do is basically go through its full range of motion here, all the way down, all the way up, and then we'll leave it in the middle. That's going to be our yoke roll axis. So we already did that, so we'll go ahead and put finish. All right, now we're going to go to do the engine throttle. So this one doesn't tell you to leave it in the central position because it doesn't have a neutral center position. So we're going to just go through the minimum motion of the throttle here, and then we're going to go all the way to the top, and then we're going to click finish here. Okay. Oh, there it goes. It responded already. All right, now we're going to do the pitch. So we're going to calibrate the pitch. This one does tell you to leave it in the central position because it does have a central neutral position. So we're going to go ahead and do this one here. So we go all the way to the top, all the way to the bottom, and then we put finish. And then we're going to do the flaps. So that's going to be this one right here. So we'll just go all the way to the top and all the way down, and then we'll put finish. All right, so they're all done now. All right, so right there you can pretty much see everything we're going to play around with right now. So I'm going to go ahead and do the roll axis first. So you can see that as I'm moving the potentiometer, it's going through its range. And you can see that right there, for example, I'm not even all the way to the end yet, but the yoke is already all the way over. So sometimes these potentiometers, they'll actually indicate their maximum or minimum voltages when they're not really at the maximum and minimum positions. So the plugin is going to translate that at that's being its maximum and minimum position. So there's really nothing you can do about that unless you get very high quality potentiometers that reflect accurately. So we go all the way from there to the other side, and then we go to the middle and leave it there. Now this one right here is going to be the throttle, and we already calibrated it. So you can see that right now we're all the way out. So when I go this way, you can see the throttle is moving, and it responds pretty quickly. So if I go in and out pretty quick, you can see that it responds accordingly. Okay, I have a little problem with the pitch because it wasn't connected to the right one, so we're actually going to have to calibrate that one again. So we go to analog calibration, and we're going to do the pitch, and then it wants us to go from maximum to minimum and then leave it somewhere in the center, which I guess would be around right there. And then we finish the calibration. All right, so now let's see what the pitch does. So you can see that it's coming out, it's going in, so it's working fine. And it's, see, sometimes my potentiometers, like right there, has a little bit of noise, so that's just the quality of the potentiometer. There's nothing you can do about that. I mean, we already have the capacitor here so that it can help with that, but it's still, the majority of it is pretty good. You see that? It's very, very smooth. So it just depends on the potentiometers that you have. All right, last but not least, this is the flap lever. So this is going to be a perfect example to show you the inversion again. So you see that right now I'm going up and my flap lever is going down. You see that? So right there I'm still not at the full range, but it's already all the way down on the flaps. So that's just something that, you know, like I said, depending on how the potentiometer actually responds electrically, that's going to depend how it behaves. Now let's say you had already put this in your setup, and obviously it's backwards, right? All right, so the good thing is that we can go to the plugins, SimVimX input options, and then we can move our axis that we want to do, and this is going to be the flaps. So we click inversion, save and reconnect. So there, now it should be inverted. So now when we go up, the flap is going to go up, and then as we go down through the range, the flap is going to go down. One thing that I did want to mention real quick is about the partial movement and calibration for that. So if you remember correctly, if you wanted to make either a rotary or a linear potentiometer have its full range of motion with only a limited range of motion of the actual potentiometer, then you will need to do what I'm about to show you next. So if we go over to my overhead again, let's say for example this potentiometer that I use for my roll axis. So right now it pretty much works from pretty much this much to about right here, you know, which is almost the full range. But let's say you didn't want it to move that much, so you wanted it just to be maybe like from right here to right here. So in the simulator here, we can go ahead and go to plugins, SimVimX, analog calibration, and let's just say right now you see how it says 0 to 1023, the center is 579 for the roll. So let's say we wanted to calibrate it so that it wouldn't be the full range. So you would just like move it, let's say about to there, and then I'll slide it over to about right there, and then we're gonna leave the center right about where it's at right now. So we're gonna go ahead and put finish, and there it's done. So now when we move it, you can see that it reaches its full motion when I'm right about where I said the maximum was, instead of being way over here where it was before. So now if I go to the other side, I think I set it to about right here. So you can see that right there it already reached the full 90 degrees to the side there, instead of being somewhere up here where it was before. So that's how calibration for partial movement works. Well, I guess that's going to be it for potentiometers. As you can see, they're not that hard. The only thing that I will tell you is that all the times that I played around with it, this is one of those things where you really need to make sure that your wiring connections are solid, that they're not kind of loose or going to be flaking around, because it will make all your devices like your, you know, your throttle, your yoke or whatever is going to be jumping around like crazy. So you need to make sure that you use that capacitor, you know, for between the 5 volts and the ground rail, or on each individual potentiometer. And you do need to make sure that all your connections are very, very well made, preferably soldered, because otherwise you're gonna be very frustrated. All right, well, I guess that's gonna be it for this video. Thank you very much for watching, and like always, I'll see you on the next one.